So it's now February 13th. So we're on to our third report for plant design. So basically we just gotta like design the reactor, like how much weight of catalyst, what's the size, what's the area, what are the rate equations, the whole overall reactor. So it's a packed bed reactor. So basically there's a bunch of like catalyst packed into a tube, and then we're running our gas phase reactants through this tube. And then these gases will be adsorbed, so basically stick onto the pieces of particle in this tube. And then when they're stuck there, they'll be able to react. And then that's how this reaction is going to happen. So basically where I'm at right now is reading the reaction engineering textbook and just looking at the equations that govern the catalyst. And I'm going to figure out what's the pressure drop for the amount of catalyst that we're going to have in our system. Because the pressure in the reactor is going to change, the temperature's going to change, the flow rates are going to change, and you have to figure out how much everything changes so that you can accurately model the reactor. So basically we have all of our equations and everything, plan the whole thing out. Just gotta figure out what all these terms are and make sure I have all of these values. And then when that's done, I can move on to the energy balance equation. 9:40 a.m. Programming paradigms lab, programming paradigms lecture, and then some more reactor design. Let's get going. Lab done. Working on my reactor design. Alrighty boys, so it's 4 p.m. here, another day in the books. So I finished the isothermal case. The only issue is the pressure drop is really low. So I'm not really sure if everything's correct, but like the process looks good though. So sent it to the TA, I have a TA meeting tomorrow. And in the meantime, I'm gonna go home now. Okay guys, so update here, it's now 12:40 a.m. So good news, the TA looked over everything and she said, honestly, that it looks good. So basically, this is where we're at with our reactor design. We have all of our operating conditions here. I have all of my parameters used to find the rates of the reactions and the Ergun equation values, which finds the pressure drop in the system. And basically what we're doing is we're saying at every kilogram of catalyst, how much of each flow rate do we have? And we keep iterating this down until we hit the target flow rate or until we can't produce any more product. So this is, okay, at this much catalyst weight, we get these output flow rates. These values are very similar to that of our HYSYS simulation. HYSYS is like a software used to simulate chemical processes, but for this report and for this project, we have to, like, I have to fully design the reactor, so I can't just use whatever values I got in HYSYS, but it's a good indication of like, if they're similar, then okay, I know I'm doing something correct, but I have to like prove everything. So basically it means that everything we've done here is pretty much correct. So the only thing though is the reaction rates are pretty high because those rates are found using a micro reactor. Micro reactor being very small, it doesn't take long for the gas to disperse and react. So the rate of reaction will be higher than that in a large reactor. So these kinetics might be too high. So the thing to do next would be to see if I can scale down these values a little bit to see if I get more accurate results. Yeah, that'll probably be it for the isothermal case. So now what we'll have to do is we'll have to add the temperature dependency, because obviously the rate of reaction changes with the temperature. Right now I'm assuming isothermal case, which does not reflect real life. So I'm gonna have to implement that. And after that, then I'll just mess around with it and optimize the reactor. It's February 16th today. And this isn't due until, I think it's like March like 1st or something like that. But you need to finish this in Excel, and I've got to test a bunch of different cases, optimize, then I have to write like a 20-page report on it. There's still lots of work to be done. So tomorrow's a new day. I'm gonna go to bed now, meet with my TA tomorrow, and we'll pick up from there. Alrighty guys, what's going on? So it's 6:30 a.m. here. I have my final reactors design due at 1 p.m. today. So basically I have not slept in I don't know how long. Pulled an all-nighter. I've been grinding this report out all night. Just typing up a ton of stuff here. I have finished my final reactors design. So here's my simulation in Excel. Basically what we're doing here is there's just a couple sections left to crunch out for this final report. So I had a midterm yesterday from 2:30 to 4. Got back to my house around like 6-ish. Started working on this at like 8. And I've been non-stop working on it since then. Just worked all through last night. Currently, I'm just working on the capital cost estimate here. Using my textbook, using all my charts here, and trying to get some values. Alrighty guys, it is now 12:46 a.m. the next day. I don't even know what's going on. I've literally been awake for 41 hours. That was, I think, the craziest grind of my life. So basically what we did is we typed up this whole thing, 20 pages. There's the Excel simulation of the chemical reactor. Basically, these all represent equations in one instance in time, and it solves this way until it gets to the final equation of that instant in time. And then it goes back to the first one, and it does that over and over again until it finds your final solution, which is insane.